All right, so I'm going to talk a little bit about the Poisson distribution here. So when we're thinking about a random variable that follows the Poisson distribution, we're thinking about an experiment that has some of the following characteristics. And there's some others that described in textbooks or the places that might give you a better feel too. But the experiment has a set duration, so that might be in time, so half hour, an hour, 2 hours, 15 minutes, some amount of time, or that duration could be some of the kind of space, so like a mile, 2 miles, 3 miles, something along those lines. The outcome of the experiment is just going to be a count. It's going to be how many of something that we observe in that amount of time or across that distance. So we could call these successes, events, or incidents, but it's just going to be a count. So it's going to be discrete, something 0, 1, 2, 3, 4, that kind of thing. And then the distribution is described by a parameter, mu, and that's the expected number of incidents for however long the experiment lasts. So how many we might observe during that hour or across that mile. So examples of some random variables that might follow the Poisson distribution include the number of people that come to a restaurant during a particular hour, or the number of phone calls that are received at a service center in a half an hour, or the number of potholes on a 2 mile stretch of road. Any of those kinds of things would be examples of things that might follow the Poisson distribution. So we're thinking about what are we looking to find when we have a random variable that follows the Poisson distribution. We're not necessarily looking to find the mean. That's going to be given to us. We would have maybe observed that in a set of data. What we're looking for here more is trying to find a probability that a certain number of events are going to happen during the experiment. So during that 1 hour, or during that 15 minutes, or uh, across that 100 meters, or whatever it is we're dealing with. So the formula for finding the probability of getting exactly X events in this time frame or across this space is given to you by the formula there. So mu raised to the X times E raised to the negative mu, and that entire expression divided by X factorial. So again, X is the number of events that we're curious about, and mu is the mean. It's a parameter that we have how many times this event happens on average over the course of this interval. But we might find that in a data set. Then E is just the number E, which you'll find on a calculator, or you can use in Excel as well. Find it there using the expression EXP. So an example, on average, 10 customers use the ATM every half hour. Where did we get the 10? Maybe we have a data set. We've looked at how frequently people come to the ATM, or how many people come to the ATM for months, and we see that on average it's 10 for every half hour. So then what is the probability that exactly 6 customers are going to use the ATM in the next half hour? We're just plugging into the equation. So 10 goes in there for mu, 6 goes in there for X, and then it's just a matter of punching it through, and you get 0.06305 is what you'll see for the probability. So that's the probability of exactly 6. We might be curious though about getting 0 through 6 or something like that, which would be easier in Excel to see how to do that. But as a lead up to being able to do that in Excel, the function that you type in for Excel is POISSON, so Poisson, .dist, and then the parameters that will go inside of the parentheses are X, so the value that you're curious about. In the example just a moment ago, it was 6, and then mu, in the example a moment ago, that was 10, and then false is the option that we use when we want to know the probability of getting exactly X events. Now, if we wanted to get 0 through X, so 0, 1, 2, 3, 4, 5, or 6, the probability for that then what we would change is the option false becomes true. So Poisson.dist, and then again x, mu, and now true would give us the probability of getting x or fewer. So if you wanted more than x, you would just take 1 minus uh, that thing. So what's the probability of getting 7 or more? It's just 1 minus the probability of getting 6 or fewer. So let's go to Excel and check out a couple of examples, see if we can get the same value that we saw before for mu is 10 and x is 6. And then also let's do an example with a milkshake machine salesman. And the experiment is just going to be 1 month. Look at x as the number of milkshake machines that the salesman sells. So coming over here to Excel, I'm just going to say Poisson dist, and I wanted to look at one where what's the probability of getting exactly 6 when the mean is 10, and I choose false, and it gives me 0.06305, which is the same thing I had figured before, just using the formula. Let's suppose we want the probability of getting 0, 1, 2, 3, 4, 5, or 6. Well, the only thing that's going to change here is going to use Poisson.dist, and now 6 again, 10 again. Now I choose true, and it's going to give me something larger than 0.063 because it's going to include probability of getting 6 plus the probability of getting 5 plus the probability of getting 4, and so on. And I get 0.1301. So then if I want the probability of getting something larger than 7, or excuse me, larger than 6, so 7 through infinity as it were, I would just do 1 minus this other value, and that's going to tell me the probability of getting, right, probability of 7 or more, okay, would be 1 minus the probability of 6 or fewer. So those are those examples. Now, or that example, now let's look at this question here. A traveling salesman sells milkshake mixing machines and on average sells 7.9 machines per month. Needs to sell at least 3 machines each month in order to stay in business. Otherwise, he will shut down. What is the probability he'll have to shut down after this month? So that means what's the probability that he sold 0, 1, or 2? Because 3 or more, he'll be able to stay in business. So the probability of selling 0, 1, or 2, I'm just going to bring that over here. And I think this follows the Poisson distribution because that's something that I'm counting up. The milkshake salesman is going to sell 0, 1, 2, 3, 4, 5, something like that. How many events like this are going to take place, the sales, in a certain time period? In this case, it's a month. So it roughly fits that description of the distribution. And so here then I'm going to type 2 as my x value, and then the mu, the mean here, is 7.9. The question tells me that on average 7.9 machines are what he sells. And then here I want true. So the probability that he sells 0, 1, or 2. So I enter true there. And I come up with 0.0148. And that would be the answer for that.